Good morning, everyone. Welcome to day 3 of Google Next. How's everybody doing? Did you guys enjoy the party last night? Few nod of hands. Great. Thank you for making it first thing after the party. I know it's hard. I'm super excited to spend the next few minutes talking about next generation storage. How do we design storage for the future? I'm Sameet Agarwal, VP and GM for storage for Google Cloud. With me co-presenting are Nathan Thomas, Senior Director of Product Management for storage for Google Cloud, and Christopher Ang, Software Engineer at Snap Inc. So let's get started. Before we begin, I want to talk about my other job. You know, like Bruce Wayne and Batman, Clark Kent and Superman, I also have 2 jobs. Of course, my day job is building storage products for Google Cloud. But my other job that I'm incredibly privileged to have is leading teams that build and run storage for all of Google. Many of you are probably familiar with GFS or Colossus, which is a large-scale distributed file system that is pretty much the foundation for all storage at Google. Systems like Spanner, Bigtable, BigQuery, and almost all products that you know of in Google, search, ads, YouTube, photos, cloud, and even the newer ones like Gemini training and serving, all run on Colossus. Colossus runs on both hard drives and SSDs and can scale to exabytes of storage and multi-terabytes per second of egress bandwidth. Having built and run storage systems at scale for a long time, there are a few magical superpowers we think are critical for the success of any modern storage system. A storage system at its foundation has to be highly reliable and secure. Google was among the first companies to talk about this notion of a data center scale computer, how you take all the computing resources of a data center and use it as a single computer. But what we realized over the years is that data center is not enough. You really need to take a global view. You need to go beyond a data center to a region or, in fact, an entire continent and be able to move workloads. So you need to move workloads and storage between data centers for either load balancing reasons or fault tolerance reasons. And that's very, very important for efficiency as well as ease of management. The second superpower is separation. You've probably all heard about separation of storage and compute, that you can elastically scale compute while keeping storage the same. The other really important separation is separation of performance from storage. You want to be able to take both compute and the amount of I/O workload is using and scale that while storing the same amount of data. This allows you to mix really hot workloads, warm workloads, and cold workloads in the same storage system and maximize both the capacity and the performance of the system. What it also allows you to do is you can burst the amount of I/O for a particular workload dramatically, but not have to provision for the peak of all the workloads that are running on the system. The third key attribute is a single, very simple programming model. You want a single, strongly consistent stack that all the applications can write to, instead of having applications worry about eventual consistency or asynchronous behavior, regardless of the performance of the system. And lastly, you want to be able to manage all of your storage as a single fleet and manage it centrally so that your cost of managing storage does not scale linearly with the amount of storage you're managing. There is no way we would manage all of Google's storage if we had to scale our management team the same size as the size of storage. So I wish there was a magical way where all of these attributes were available to all the cloud customers at the same time. But bringing these capabilities to the cloud has its own set of challenges. First, compatibility is super important. Most of the applications that are moving to the cloud cannot completely rewrite themselves, and they expect to get their familiar block, file, or object APIs when they move to the cloud. And the cloud storage systems have to adapt and provide that compatibility. Performance is super important to Google as well. But it is important when cloud workloads are migrated, that we are able to give them the performance, whether it's latency or throughput, without having to re-architect the app completely. And we have to integrate the management of storage, including security and compliance, into whatever your existing workflows for the customers are. So the North Star for us in storage is to make sure that we are adapting our storage systems and optimizing it for the workloads that are running in the cloud. There are a few categories of workloads that we think of. There is archive storage, cold storage, backups. This is probably the first workloads that move to the cloud, and the cloud supports them really well already. There is content storage and distribution workloads, things like static website hosting, photo and image storage, or live stream videos, where you're storing data in the cloud and streaming it out to the internet. The third category is data-intensive workloads, analytics, HPC, and increasingly AI training and serving workloads, where you have a massive amount of storage in the cloud, and then you take the power of parallel computation, where you take a large number of machines and process the data. And lastly, you have traditional workloads, traditional enterprise workloads like VDI, Windows, databases, SAP, GKE applications, and so on and so forth. In this talk, we'll mostly focus on the last two categories. So let's talk about data-intensive applications and how we are optimizing storage for that. So the notion of having a single data lake, data warehouse, data lakehouse is now pretty standard for all analytics use cases. Cloud storage, Google's cloud storage, also known as GCS, is the best storage system you can think of building a data lakehouse. First, you want the ability to be able to store all your data in a single data repository and be the single source of truth for all your data. GCS can store all that data and provide all the fault tolerance, data protection, and reliability you need so that after you collect all the data, you don't lose the data that you just stored. From a price performance and scalability point of view, GCS provides almost unlimited scale. You can scale to exabytes of storage and tens of terabytes of bandwidth. So you have no limit to your analytics applications. But equally important is price performance and making sure that you can store hot data or cold data and manage the costs of that storage appropriately, and GCS provides you all the tools. GCS is also integrated into a very rich ecosystem of APIs and frameworks, like open source frameworks, Hadoop, Spark, Kafka are all well supported. Third-party ISVs and partners like Snowflake, Databricks, Confluent, and our own best-in-class first-party products like BigQuery, Dataflow, and Dataproc. GCS also has a very simple, strongly consistent API that you can use regardless of the tier of storage or the location of the data that you're storing. And once you have all of this data, we provide you all the access control tools to do fine-grained access control, as well as lineage and governance for all your data. But with the rise of AI, increasingly the data lakehouse is moving to an AI lakehouse, where you need to support these new AI applications. Not only do you have to store structured and semi-structured data, but you now also have to store all the unstructured data in the lakehouse. From a performance point of view, all the requirements we have of the data lakehouse are still valid, but you also need very low latency, and you need to scale to a very large number of metadata operations. The AI applications are all come with their own very large number of frameworks and APIs like JAX and PyTorch and TensorFlow, and we need to support those. And data governance is as important as ever, but you also need to worry about protecting your model that you may have spent days, weeks, or months training. So we think of evolving cloud storage to a cloud AI storage with a very simple vision. You store your data exactly once, and you can access it anywhere with any performance, use any of the frameworks and APIs that you want to in this category, and with unlimited scale. Let's look at it a little bit deeper on what the architecture of cloud AI storage looks like. At the bottom of the stack is your familiar cloud storage. This provides you an unlimited scale data repository, which can store all your data. More importantly, it provides you a single source of truth and a single control point for all management. So you can do all your management operations on that one copy of the data. On top of it, we have a series of caches. These caches are important because they provide you performance and location flexibility, but they also integrate into all the different APIs that analytics and AI applications expect. And on top of that, we have a bunch of optimized connectors for analytics, whether it's Hadoop and Spark, or for AI like PyTorch, JAX, and TensorFlow. This cloud AI storage sits at the foundation of the data processing systems and AI systems, whether they're open source, third-party, BigQuery, Vertex AI, or our first-party products. Let's see cloud AI storage in action in a little bit more detail, especially around location flexibility. One of the first choices you have to make when you store data in cloud AI storage is what location are you going to store the data? We provide a choice of 3 locations for all the data that you store. First is a regional location. This is probably most familiar to everyone. If you do not care about accessing your data from more than one region, and you do not have any needs for disaster recovery protection, this is your lowest cost and best choice. You store your data in one region, you can access unlimited amounts of it in that same region, and it's the lowest cost. But many of our customers either have a regulatory requirement for disaster recovery, or they just worried about losing the data when a region fails, or they need very high availability. In that case, we provide a dual region bucket. A dual region bucket, you can store your data once, and we will transparently replicate it to 2 regions within 15 minutes if you use turbo replication. This guarantees you an RPO, a recovery point objective, of no more than 15 minutes for your data. But Google Cloud Storage is the unique cloud solution which provides an active disaster recovery system. What it means is, as soon as you store your data in one region, it's accessible from both regions at the same time with full consistency, even before the data is replicated. This allows you to access your data rather than worrying about a fail-back and a failover system which normal disaster recovery solutions provide. What we are excited about is we are adding a new third option for data-intensive applications to store their data, which is the most flexible. This option is a multi-regional bucket with anywhere cache. The idea here is you can store your data, and we'll store it in 2 regions, which gives you disaster recovery protection. But then you can access it from any other region in the same continent. So now you have full flexibility of accessing your data from all of the different regions while storing it on only one place. Let's dig into a little bit deeper detail of how this is done. When you use Cloud Multi-Region plus Anywhere Cache, at the heart of it is a GCS multi-region bucket. This is a unique feature of GCS where the data, as I said, is stored in any 2 regions in a continent. This makes sure you have a very low-cost, active disaster recovery system, and you do not lose your data when any one region is lost. But this data is accessible from all the regions in the same continent. Now, for data-intensive applications which are going to read a lot of data, there is implications here both of cost and performance, and that's where Anywhere Cache comes in. Anywhere Cache is an SSD-based cache that you configure in all the zones, in all the regions you want to access the data. The cache will automatically cache the most frequently used data, and now the VMs which access the data in the same zone read it from the cache instead of going to the multi-region bucket. What this means is there is no egress cost for accessing this data, as well as you have improved performance. And by co-locating the compute and the storage in the same zone, we can unlock a very large amount of read bandwidth, so you can read large amounts of data, which would not be possible if you were reading it from the underlying bucket. So multi-region plus Anywhere Cache configuration unlocks a bunch of use cases unique for data analytics and AI use cases. There are customers who have unique VM shapes or GPU or TPU hardware requirements, which may only be available in some regions in a continent. There are many of our customers who want to do cost optimization and they try to use spot VMs, and the availability of spot VMs may be different for every region. Or there are customers who have unique requirements to co-locate their compute with other applications running in different regions for latency reasons, and so they want flexibility in compute location. Regardless of the reason, with a multi-region plus anywhere cache, you can locate your compute anywhere in a continent, access the data without having to make copies or replicate or deal with consistency issues. And as a bonus, you get built-in disaster recovery protection for all your data. With that, I would like to invite Christopher Ang, software engineer in Snap, to tell us a little bit more about how Snap has built its data platform on top of cloud AI storage. Snap is one of our largest and oldest customers of GCS, especially when it comes to data platform, AI, and analytics. I would like Chris to tell us a little bit more about how they built the platform and what are the challenges they see in the future. Over to you, Chris.
Hi. Can everyone hear me? Cool. Thanks, everyone. Thanks, Sameet, for the introduction. Oops. First, I'd like to give you a little bit overview about Snap Inc., the company, and Snapchat application. Basically, Snap Inc. is considered a technology company. Snapchat itself, the product, is an application that enables users to express themselves, live in the moment, learn about the world, and just have fun with one another. As of the end of 2023, Snapchat has an active community of about 414 million daily active users worldwide. And Snapchat believes that AI ML presents a really great opportunity to continue to drive value to our users, as well as continue to drive value to our business partners. At Snap, we also like to empower our engineering team to build workflows that are enabling them to collect the logs and metadata that they need to power their AI ML workloads. We also build tooling on top of Google Dataproc and Google Cloud Dataflow to accelerate the ability for developers to get their pipelines into production. What I have here on the screen, going from left to right, is a generalized pipeline that can kind of show what some teams are building at Snapchat and how they're leveraging this with Google Cloud Storage. On the left-hand side, starting with the logs and metadata, we basically collect data from client applications, in this case, whether it's the iOS or Android application or Snapchat's web app. And we also collect server logs, and these are all sent to Google Cloud Storage. From Google Cloud Storage, we have a Dataproc job running on Spark, or using Spark, that is able to join this data both on the client and server side to basically form something that we might consider like a session. Those are then stored back into GCS again. And we finally have a pre-processing flow, which is where we actually transform that data into machine learning model-friendly formats that will eventually be fed into our training pipeline. As you can see here, throughout multiple stages, we do have a large dependency on GCS, both for reading and writing data, which causes some bottlenecks from time to time, which we'll address in later slides. I'd like to clarify a little bit about where Snapchat would like to go over the next 2 to 3 years. Basically, we believe that training with larger data sets will empower better models and at the same time provide more value to both our users and our business partners. In order to do that, we must do so in a cost-effective manner. One of the ways to do that is to explore different opportunities or different types of bucket types, as Sameet mentioned, in both the regional and multi-regional space, as well as continue to drive the overall end-to-end latency of these pipelines to continue to deliver on model freshness. We believe that model freshness is a key objective in order to provide more enriching content to users, as well as provide more insights for our business partners in their campaigns at Snapchat. What I have here is a really general graph that shows where we are in 2023 on the blue and where we would like to get to in 2024 and 2025 in red and green respectively. What I have on the left-hand side is basically kind of the relative storage volumes we would like to achieve over the next 2 years, starting from 2024 now and into 2025. So going from 2.6x where we were in 2023 and to 6.7x in 2025. On the right-hand side, I'm presenting an overview of where we are with the read throughput or the egress volumes. Again, using 2023 as a baseline, we'd like to go to 1.5x peak egress throughput in 2024 and potentially 2.3 peak egress throughput in 2025. Now, transitioning over from egress, one of the challenges we run into is that bandwidth is a limited resource. What this means is that it requires time from GCP to provision the hardware and deploy that hardware to meet our needs. At the same time, Snap must do its due diligence to forecast the requirements that we need well in advance so that GCP can oblige our requirements. And in that regard, there are some pros and cons that we've experienced when choosing between multi-regional and regional buckets. From a multi-regional perspective, the ability to use data across where our compute resources are desired, for example, our GPU, TPU, and bare CPU resources are available, is one of the best, or one of the pros with multi-regional buckets. However, one of the cons is that the peak egress is a concern there. It has a generally lower peak egress than is available with regional buckets. On the other hand, with regional buckets, as Sameet mentioned, one of the cons is that everything is located in a single region. That means that if there's any kind of outage, it would significantly affect our ability to execute our pipelines. Similarly, from a single region perspective, basically, there's only limited compute there, meaning that if we want to deploy or co-locate our data closer to where available compute is, whether it's GPU or CPU, it's a lot harder to do and a lot more costly to do. And as mentioned, even in both multi-regional and regional cases, one of the challenges is still the egress limitations. That means that irrespective of the type of buckets we choose, when we have very large spikes in terms of egress utilization, this can cause significant amount of retries, which will significantly affect the cost efficiency of our pipelines. We believe that one solution to this is anywhere cache, as Sameet pointed out earlier. One advantage to anywhere cache is the ability to deploy new storage infrastructure without all of the delays that we would have had to deal with when using the traditional storage options that GCS had to offer. This allows us to scale in regions where we previously didn't locate the data, but now we can deploy that data and be able to leverage the CPU, GPU, TPU that we need to do these, to run our workloads efficiently. This also avoids the need for us to manually have to do any kind of migrations, whether it's transitioning from multi-regional to regional or vice versa. So in summary, what I should say on the previous slide is one thing I do want to take away from you is that storage is not the problem. Being able to store petabytes or exabytes of data is not the issue here. It's about the ability to quickly consume that data to really turn around and finish our workloads as efficiently as possible. Now with that, I'd like to kind of summarize where we are and where we're looking forward to go. One is to continue to grow engagement on Snapchat. We'd like to continue to increase the returns of Snapchat's business partners. And to do so, we'd like to continue to do that with training with larger data to continue to improve our ML models. And we'd like to continue to achieve these with a very cost-effective manner. Lastly, we'd like to continue our partnership with GCS to evaluate the advantages and benefits of using anywhere cache, especially on our bandwidth-constrained buckets. And with that, I'd like to turn it over to Nathan, who will take it over from here.
Thank you, Chris. Thanks a lot, Chris. So I want to remind us of where we are in this journey that Sameet began talking to us about with regards to designing storage that is really effective for particular workloads. So this is part of that next generation storage push that we described. We've talked a little bit about how we're working on AI and ML pipelines, and particularly talked about cloud storage, and we saw how Snap is using that to accelerate their pipelines. But we also really want to pivot and talk a little bit about enterprise. Now, I do just want to give us a moment to get our bearings, because it can get a little overwhelming thinking about all the different storage offerings that we have. So we heard a little bit about Object just a moment ago. And Object is our high-scale storage solution that's network accessible and is powering a lot of the largest workloads running in Google Cloud today. But we also offer block storage and file storage. When we talk about block storage, we're really talking about hyperdisk, persistent disk, and local SSD. Which show up a lot like physical storage devices that are connected to your VMs. When we talk about file storage, we mean file store, NetApp, and parallel store. These are network-attached file storage solutions, again, that are connected to the VMs that you're using. When we talk about the object storage, of course, we mean the cloud storage components, so I already heard a little bit about that. But let's start by taking a little bit of a look at how block storage is supporting enterprise workloads. So enterprise apps like RDBMSs or SAP or large-scale GKE applications have a really wide range of performance needs. And so it can be a very interesting challenge for people to actually figure out what's the right set of performance that they need for their application, and then which type of block storage is going to suit that best. So finding the right IOPS and the right throughput for those workloads, and of course with the right latency characteristics. It also means that ensuring that you can have the right capacity and scale that use to match the needs of that workload. But of course, as with so many other challenges in the computer science world, the real problem is doing that in a way that's cost efficient. So can you achieve those goals while actually having the price points that you need that match the specifics for your business? So one of the most common technological solutions for this is block storage. So it gives you this high performance capability at reasonable price points. But what we find talking to customers is they often feel like they have to spend a fair amount of effort to try and identify the right block storage at the right price points. And oftentimes capacity and performance are coupled in block storage offerings, which means that even when they spend all that effort, oftentimes they'll find they're not getting an ideal, optimized, efficient solution. To answer that problem, we launched Google Cloud Hyperdisk. So this solves that problem by decoupling the capacity and performance elements for block storage. This is then divided into a set of different offerings that can then match the specific needs of your applications for block storage. So hyperdisk throughput is targeted at scale-out analytics and other throughput-oriented workloads that are very cost-sensitive. So it's sort of the lowest price offering there. Hyperdisk Balanced is more of a general purpose volume type, so it probably fits the widest range of needs for applications running inside of Google Cloud. And it still offers a phenomenal set of performance, so up to 60,000 IOPS and up to 2.4 gigs a second of throughput. Hyperdisk Extreme is a bit more of a premium SKU, so it's offering the higher performance that's needed for things like SAP HANA and high-end SQL Server and Oracle deployments. And of course, it has an SLA guarantee associated with it, which is really important for those types of applications. And then we're very excited to have just announced Hyperdisk ML. So Hyperdisk ML is really designed for hydration of large amounts of data, particularly for things like training pipelines, where you're going to have a very large cluster of compute which needs a rapid provision of the training data that's going to go to it. So with Hyperdisk ML, you can attach up to 2,500 nodes, and you have 1.2 terabits of throughput. That means you can get those nodes in your compute cluster for your ML pipelines running very quickly, get those GPUs in service very quickly. So a very, very exciting new announcement from us. For all of these SKUs, performance is fully decoupled from capacity, and it's unrelated to the VM that's being selected. So you get complete flexibility in the block storage that you allocate to your application. This is a major benefit for customers. Now, while it is wonderful that we have the right volume types of the right capacity and the right performance for your workloads, we also hear from customers that they have some concerns about the need to provision for the peak that they're going to see for those workloads. That is, you've got to have the right set of capacity for the maximum case you're going to experience in the day. But in reality, the average utilization can be quite a bit lower than that. So they feel like they're over-provisioning on the capacity or over-provisioning on the performance for these volumes. So that can actually add up pretty badly on an individual application. But then when you think about having an entire suite of workloads across your enterprise, you can wind up with all of them in that configuration, and you have a lot of over-provisioning effectively compared to where you expect it to be. This, from customers we hear, is sometimes means that they're getting as low as 20% utilization on the capacity and performance that they've allocated for their block storage devices. To solve this, we launched storage pools. So storage pools let you aggregate your demand across a range of, or aggregate your capacity and performance across a range of workloads that are going to be running inside of your environment. This sort of lets you have your cake and eat it too, because it means that you now have provisioned for peak, but it means that you can actually share that peak capacity across a wide set of workloads. And there's really no workload changes necessary to make this all happen. So it's a very accessible way to save money. You build pools based on the underlying volumes that you would use otherwise. So you pick your Extreme or Hyperdisk ML, and then you decide on the performance and capacity associated with that pool. Now, there is an option there where you can either pick standard or you can pick advanced performance and capacity. And in the standard case, you are provisioning basically as the sum of the total set of volumes that you would be using in that pool. If you go for the new advanced capabilities, you're going to see that it's more of a thin provisioning model. So it opens up additional cost savings for you. Advanced capacity just launched in GA, and then advanced performance is in preview now. We're hearing from some customers that the savings here can be on the capacity side as much as 50% with advanced and up to 35% on the performance side. So that combination of hyperdisk so that you have the right volume and pools so that you can actually utilize it across a wide range of resources is a pretty big needle mover in cost for block storage inside of Google Cloud. All right, let's move on to another workload that we're seeing really experience some explosive growth inside of Google Cloud, both in enterprise and in cloud first. These are stateful multi-reader and writer applications. So, for example, you might have an application spread across thousands of GKE pools where each one of those needs read and write shared access to the data that's being used. So they have to ideally be able to do that without having any of the kind of impacts from a failover. So if you see a failover of pods from one to another, no PD detach and reattach is necessary. No time is lost in that regard. And they need to have non-disruptive upgrade paths inside of that. So our solution to this is file store for GKE. Now, while file store for GKE is very focused on these high-scale cases where you need an NFS volume attached to a large number of nodes, it also is really designed to support a wide range of enterprise applications. And of course, as with hyperdisk, the design is really to have a tier of offerings so you can match your performance to your specific business needs. So from file store basic to file store regional to file store zonal, you can pick the set of options you need, ranging from a terabyte up to 100 terabytes of size and ranging from 100 megabits a second up to 26 gigs a second of throughput. So there's a lot of options for you to go and match what you need. Now, while file store does meet the needs of a wide range of enterprise customers, we also hear from customers they have some workloads where they would really rather see a file option that looks a lot more like what they have on their on-premises environments today. So this might be for Microsoft Windows applications that need SMB shares, or it might be for mission-critical enterprise NFS applications. You might be something like a VMware migration going into Google Cloud. For these use cases, we've recently launched Google Cloud NetApp Volumes. So Google Cloud NetApp Volumes give you the same experience of using NetApp, but in a managed cloud service that you use in a pay-as-you-go fashion. It's got all of the same basic tools and the same basic performance characteristics, and it gives you that accessibility to scale it along with your application as you grow in the cloud. And as with all the other storage offerings we discussed, of course, there's a range of performance and price options here so that you can match it to your specific needs. So we've so far had standard, premium, and extreme volume types, and we are just announcing some changes in the capabilities, particularly on extreme. We're moving from 4.5 gigs a second of throughput up to 12 gigs of throughput, so more than about 3x growth there. And we're increasing the volume size up to a petabyte for maximum, which really unlocks some of the biggest workloads that you can use with this. On the premium side, we'll be moving to 6 gigs a second of throughput. And then one of the things we hear from customers a lot is they would really like to see smaller volume options in this. So we're announcing Flex, and Flex is going to let us go down to 1 gig volume sizes. A lot of times we see people moving workloads from on-prem filers, and they've got a lot of small volumes they'd like to get moved in. This lets you do that without having to over-provision on the capacity side, which is pretty exciting. So these are going to be changes that are coming out later this year and be available across 15 regions. Now, when we talk about customers running these mission-critical enterprise workloads in file, there is a different set of expectations that come along with that around data protection. They're really expecting a comprehensive set of data protection offerings as well as management, and they want to be able to have that across all of their RTO and RPO needs, whether that's in a region or whether that's in a zone. They've got to have that protection. So customers need short backup windows, with the ability to easily and quickly recover from a range of problems, from application data corruption to other similar issues that they might experience that may be user-driven. They also need a way to have a cross-zone high availability with very low RPO and RTO across a wide range of applications. And they need the kind of built-in disaster recovery Sameet was describing earlier across a region, whether for geo-redundancy purposes, perhaps to comply with financial regulations. With capabilities like snapshots, regional disks, and async replication, we are addressing all of these issues today. And we've built these as first-class primitives into the storage solutions, file, store, and for NetApp, which means they're very simple to take advantage of and get access to right now. All right, well, I hope you're able to see a little bit today from hearing from Sameet and Chris and myself about how we're constantly innovating inside of Google Storage to make sure that we're building next-generation storage that meets the specific needs of your workloads. You're going to find the capacity, the performance, the price points, and the management that you need to make using storage inside of Google effective for your businesses.